Hello and welcome everyone to today's webinar on Oracle Red Bull Racing Esports Real-Time Player Analysis. Thank you for joining us. My name is Terry Van Cleve and I'm a Marketing Event Manager for the Developer Initiative here at Oracle. Today, we're excited to lift the lid on how Oracle Cloud Infrastructure is being used to develop solutions that will allow esports players to race online and compare their driving against Max Verstappen and Sergio Perez. We'll also be recording the session, and the link to the recording will be sent to you via email in the next couple of days. If you have any questions during the webinar, we've set up a channel in our developer public Slack called Webinar Red Bull Esports that you can access at the QR code or on bit.ly/odevrel_Slack. Once you're in, you'll land in the general channel, and from there you can search the webinar channel. We'll also be checking the Zoom chat and the Zoom Q&A areas throughout the webinar, and we'll open up for live Q&A after the demo. Today's webcast will be presented by Miles Jackson, a consulting member of the technical staff working with Red Bull and Red Bull Esports as a solutions architect. So without further ado, I will hand it over to Miles.
Okay, welcome everybody. This is kind of exciting. So we've got quite a few projects on with Oracle Red Bull Racing. The Oracle logo is on the side of the car. But what basically I want to talk briefly about that, and then do some of the stuff that we're doing with the esports stuff, because we can lift the lid on that, which I'll talk about in a minute. But yeah, some good stuff. Briefly talk about the partnership. Couple of the big projects that we've got going on with them, but then I want to dive straight into the esports and the telemetry and what we're doing there. I'll build that out, show a couple of cool things we've done with it, but then I do want to break it down, get into the architecture, the data flows of that, what we did for that. I will attempt some live demos, 2 of them, and then do a code breakdown as much as we have time for. And then I do want to bring it back at the end for industry applications, as this does actually apply. It's cool race cars, but it also actually applies to many industries, is this idea of fast telemetry and large ingestion of data to the cloud. Briefly, so a couple of the big projects that Oracle and Oracle Red Bull Racing have done together is, one of them is that there's a new engine formula for 2026. So Red Bull Powertrains has been designing a new engine, and so far all the computational fluid dynamics for that engine and that simulation stuff has been done on the Oracle Cloud. So that's one of the big things that we're doing with them. The other one you might have heard of, it's been in the press a bit, as well as the race strategies for each race, the F1 car. So they run big Monte Carlo simulations where they're changing all the variables and do that, and they do a whole bunch of pre-race setup and simulation runs and do that, but then also live during the race. There is a big HPC that's spun up, and they're doing basically billions of simulations per hour during the race to help them make the best decisions there. Now, these 2 things, that's pretty much all we can share about that stuff, because they're so black box. Any sort of thing that we give more about is competitive advantage that they want to keep to themselves. So the idea with esports stuff is that is an area where we have a lot more free reign to share and develop and really give these solutions out to the world of what we're doing with the esports. And so that's what's exciting about it. We can do a lot of things with it. I'll show you in a minute that the esports does pump a lot of data, and it's not far behind what you might think a fully instrumented race car is. So the esports team, the Red Bull Racing team has an esports team. They've got 6 drivers. So 3 of them are Red Bull and 3 of them are AlphaTauri, and they do share kit. So they do work a little bit together, those 2 teams. They do race in multiple series. So the Porsche Cup, Le Mans Cup, iRacing games, as well as the F122. Now we're focusing on the F122. That's the closest game that is closest to the race car that we're sponsoring. And so we're starting with that, basically. So they do have a yearly F1.com, F1 Formula One series, and we are helping them with that. We're building up the data analytics tools, and we are going to be doing in the near future a Monte Carlo simulation, just like they're doing for the real race team. So we're going to have a similar sort of setup that the real race team has, but for the esports team as well. And then after that is when we can start expanding some of this stuff to the other racing series that they're involved with. And so that's pretty exciting. So what is telemetry? If you've never heard of telemetry before, what it's basically being able to measure something and then transmit that data across somehow to something else that can record it or visualize it or something like that. So that basically any sort of data point that you can communicate across and then view it. And so in the case of these race cars, I mean, the full race car's got pressure taps, it's got, engine RPMs, it's got throttle, it's got steering, it's got tons of sensors all over the car. The game has that as well. So the game has quite a few sensors. So here's a cut down of this is actually Max Verstappen's data on the esports game, but we've got the top row would be velocity, we've got throttle, we've got brake, and then we've got gear. So that's just 4 of the channels that you get from the game itself. And I'll show you in a minute of how many we actually do get. But the cool thing about this is the first time that a world champion, we've recorded a world champion driving the esports game, but also then sharing and being as open as they are with the data as possible. So this is a snapshot from their website. So their fan site, you can go on there and you can actually hover over and look at the exact data that Max made. So that's the exciting part. Is they're being very open with the data and it's something trying to kind of forge new excitement from that. So the game itself, okay, we talked about, the car, the race car, stuff like that. There's actually 16,000 channels that comes out of the game. Now, a lot of this comes out at 20 hertz or 60 hertz. So you can change the hertz that it comes out, but there is 16,000 channels that's pumping live. And so let's say if you did 20 at 20 hertz, we're actually interpreting or pulling out about 60,000 data points per second. If you do it 60 hertz, it's 150,000 data points per second. Now we've got 6 drivers. We got 6 drivers pumping out, at 60 hertz, we got basically 1 million data points per second that we're pulling to the cloud and running real-time analytics off of. So it's pretty exciting. I'll show you in a minute, but there's just tons of data that the game pumps out. And it's a cool thing because the game is quite open in that way. So what did we do with it? What we're going to talk about today is basically how we did this, which is the Oracle virtual laps. Now they're on YouTube. So if you go to the Red Bull Racing YouTube channel, they've got these virtual laps that come out every race. And so we basically had a filming day where we had Max come in. We set up this filming studio in the garage with the old race cars that they got stacked to the ceilings. And we had a laptop. We got my laptop on here that is showing, I just logged into the VM virtual machine that was actually in North Carolina, plugged the game into the internet. So we were basically relying on the internet across the ocean. And then we piped it back to this laptop and projected on the screen behind Max. And so the whole idea behind this is we wanted to do as fast as we could. I mean, we wanted to push it a little bit by going to North Carolina back. And then we wanted to demonstrate that this is the latency that you would have encountered by doing this. And we wanted to show that it's not faked. We didn't have to fake this. So let me show a couple of I'll show you behind the scenes video and then just a sample of what is published to the YouTube channel. So this is that same scene, but you can see Max on the left-hand side. You can see the projected screen on the right. Now, if you look at, you got the top left, you got velocity trace, you got throttle, brake. On the right, you've got bottom right, you've got steering. So you'll see if you watch his steering input and you watch that gauge that we have as a steering input, you can see how well they match, as well as the speed and G load and things like that come out of the game. So let me just play this video real quick. Yeah, so that was real time. Let me show you what that turned. We then took that, the film crew cut it and did all this stuff like that, and they made these Oracle virtual laps. So let me just show what those turn into. Just a portion of one of them. They're all about 1.5 minutes long. That's how long it takes to get.
Here we are for a hot lap of Imola, one of the oldest circuits on the calendar. Braking hard for turn 1, we want to take as much curb as possible through this left-right sequence. want to cut the left curb to open up the right-hand corner to carry as much speed as we can. And then for the hairpin, you do want to have a
Okay, you guys can watch the rest of that on your own time on the YouTube channel, but there's quite a few now. It's every race they do release these. All right, so we did that in the actual minimalist way. One reason why is we want to be able, if could prove to ourselves, can we do this on such a small bit of Oracle Cloud that would be free tier? And the answer is yes, we can. We basically just have a single VM. This one happened to be in North Carolina, so we plugged in from the Great Britain over here, across the ocean to the VM that was in North Carolina, and back again across the ocean to that web app. The architecture can't be any more simple than basic simple VM in the cloud. The latency was so low. I mean, we could have done one in London. We could do, we have regions out throughout the world, but that was working, and they were happy with that. They were like, let's just do that one. Even then, the latency was low enough that the filming crew could use the data behind Max to do a lot of their video syncing with the sound and stuff like that. So it was pretty cool. They were pretty excited about it. All right, so now this is kind of a zoom in of what happens on that VM. So I've got this kind of label. There's three VMs really, but this is all, we all put this on one VM. So on the left-hand side, we got the on-premise game seat. On the right-hand side, we got the on-premise laptop that was showing on the projector. The middle part, so this is the VM. We have a bit of Python code that we wrote, which is basically just an ingester, where it just takes in the UDP feed from the game over the internet, and it comes in binary packets, and we just basically split that with a splitter and into the individual packet types. So there's 12 different packet types. Check a bit that type, send it to that thread. It'll interpret it into the binary, from the binary to our OpenTelemetry server. The OpenTelemetry server saves it, but also acts as a real-time data pusher. So in other words, so it was multi-threaded. So we had it basically one thread per telemetry type, packet type. But we also had a separate thread where it would send all the packets to the recorder, and we record that to a binary file, and just on the VM itself. And with that, we can then, that's saved. That could be a database later, things like that. But that was basically, we just wrote out a raw file that we have an F1 player that we can play back the data. So we can basically test the system by playing races or things like that. We can record and play back and use that to basically test the system without having to have esports drivers drive constantly to test our system. The part that then, so we have the telemetry server, which takes all the data through the ports, captures and holds the live telemetry, and then serves requests from the web client side. And then there's another web client side, and that serves the web client GUI to people that log into it, but also then it will push the subscribe channels to the GUI, people that have logged in, or it will then, if the user like changes what view he wants, it will then say, give me the historical data. So it'll deal with requests as well and communicate back and forth. So that's how that's set up. It's pretty simple, I should go back and say the Node.js telemetry server and the web server are based on a library from NASA, which is called OpenMCT. We've taken that, their core, what we've used there, and we've converted a few of the pieces to make it so it would run on the cloud and run on the cloud very fast. So we did have to do a little bit of tweaking, but not much. So and we do share our version of that, but it has been working really, really good for us. Okay, so I showed you a couple of graphs, but I want to show a video of, we're going to do like a widescreen version of the game real quick to show about a minute of that. And then we'll dip into some live gauges. But on this one, I want you to look at, like, we put the shifting lights on, we put the RPM on there, a few other things. But the idea is that with this, you can build whatever dashboards you want, whatever data you got coming in, whatever channels you want to subscribe to, you can build widgets and expand this however you want. And so this is just a taste of some of the stuff that we are starting to do with it. And then I'll get into some of the live demo stuff. So this is a widescreen version, but this is recorded live as well on the cloud. Let me just pause right there. We can see the types of data that starts to come out of the game. You've got tire temperatures, you've got internal and outside tire temperatures, you've got brake temperatures. All these things can start to feed into a strategy system. You got tire wear, you've got damage of your competitors, all those things can start building up a model to do predictive analysis as well. So pretty cool stuff. All right, I'm going to do a live demo now. Let me just come out of this thing. What I've got going here is I've got two different demos. I've got a demo of this, which I can show you. I've got it on my, and then I have that on my laptop, so I can show you what the OpenMCT stuff is. And then I've got a cut down version of that, which is my iPhone. I can show you live. That one's running on the cloud on that same VM in North Carolina. And I can move my iPhone around and you can see the live telemetry that's piped from my iPhone over the cellular data and back again to me on the internet. So let me do the first one first, which is the game. So I should be able to, if I got things going, just go to my local. This was the one that's running locally. I think I've got it set up. Yeah, so on here, this is all the different channels, different packet types that come through, but we've basically stripped those down and say, okay, what are the individual channels that are coming out of this? So I can say, well, let's change my clock here to, I want to show real-time data, and I want to show real-time. So I'm basically playing Max's lap from Zandvoort that he did it. So he did that one as well, which is not published yet, but this is new data. No one's seen this before. But so that's world position X, we got Y, we got Z. So you can see all the different channels that are coming out. So we have all these channels, but for 20 cars coming out, basically. So we got yaw, we got pitch, we got roll. And so, yeah, what can we do with this? So we've got telemetry, we've got speed. This is speed. We've got throttle coming through, steering. So that's the steering input. The brake is just 0 at this stage. You haven't put the brake on yet. So well, that's sorry. Yeah, that's brake. Yep. See if it ever breaks. No, we'll see. Come back to that one. Gear, engine RPM, speed. Oh, I think we're actually in between laps. Let me show the history. 15 minutes on these. These are live demos here, so that's all. Oh, must be between. There we go. Starting the lap again. So that was the restart. I have it continually looping right now. So that's the restart of the lap. So if we go back to those ones which I was just showing, which is speed and throttle and brake. There you go. Brake is working now. Steer, because we've now started the lap again. Tire pressure. So we got tire pressure, surface type. So if it goes on the gravel, things like that. Tons of different data. That's all being piped through live. We can make our own dashboard. It's got the weather coming through. It's got everything. So the nice thing about the OpenMCT is it's got all these plugins and you can write your own. So let's say I wanted to do a plugin where I overlay the G load, let's say. So I'll do a stacked. This one's called a stacked plot. I could say, well, I want to drop in G, and G. So those are the 3 different G loads. You hit save on that, and that's now in a widget that you can use and pump the data live. So right now, my client here on my computer is subscribing to these 3 channels, and it's pulling that data live. So it's accepting that data. So as you build up more and more dashboards, so if you do a big dashboard, so this guy, each one of these things is a different, there's about 30 channels here going through here. Those are rev lights and all these different things here. Oops, go back, zoom out. But as you build more, you just subscribe to more channels and you pull the data you're interested in. So if you have a race engineer that's doing tires, you have his tire data. If you got engine stuff, all the sensors for the engine, whatever you want to do, you can break it up and have different dashboards for different people, and they can subscribe to those channels. So pretty cool. All right, that went okay. Let's do another risky one. Let's do my live demo for the iPhone. Yeah, let's do that right now. So let me take this one off. And what I've got is in the cloud, I've got a similar sort of setup, but it's taking channels from my iPhone. So if I go to a website, see this works. I'll get my app ready. So there's an app on my phone, and I'm using it's an iPhone. It's called Sensor Log, and I'm using that. Let's see if it works with Zoom going at the same time. And this is it here. This is the VM that I've got there. There we go. All right, so this one, different set of channels, which I'll show you in a minute in the technical part, but we got location, we got gyro rotation, magnetometers, motion, yaw, and all that stuff. So on my phone, got my phone right here. Hopefully you can see my video of my face as well. I'm going to turn on this telemetry thing and point it to this VM that's in North Carolina and start the data. So let me turn on motion yaw real time. I'll put it to like 1 minute. So that's what we do. And let me hit go on that. All right, so there's my phone right there. I've got it. This is yaw sensor of my phone. So this is now, I'm now piping this through cellular data to North Carolina back to me through the internet to display it. Then add on top of that the latency of the Zoom meeting that we're in. So that's where we're at. So if I take this guy and I'm going to do yaw. So if you can see my face on the little camera and you can see the screen, you can see how fast this actually is working. So this is real. This is to North Carolina back. So let me yaw my phone. Let me turn my phone. I'm just yawing it back and forth now. So you can see the latency is almost nothing, almost human indetectable. So, I mean, there is some. Let me do roll. So roll again, if I roll my phone, if I twist it back and forth. So there's that, and then there's pitch. So let me pitch the phone back and forth. So we could do pretty cool stuff. We can pipe data to the cloud quite a bit. Now this one's about 82 channels that are piping through here from my phone. We got accelerometers on here. You know, I could shake it. That's the accelerometer, Y accelerometer, things like that. Gyro rotations and things like that. Magnetometers, GPS location. That's how, you know, GPS location actually comes through as well. So this is the demo that I'm going to show the code for today. The code for the esports thing will probably release in the future when we have a few things it's more buttoned up and a little bit more easy to release. But at this stage, I'm now going to talk about the iPhone demo, because that's really a minimalist version of what you can do to get started on a free tier data on the cloud. So let me close this window, and this is the data from Mac. So they're actually publishing this on the screen or on their website, but I can hover, and that's actual real Mac data. So that's kind of cool. All right, let's talk about the code now. I think that's where we're at in the presentation. Let me get back to the presentation and just make sure that's where we're at. Oh, let's do this first. Okay, so now this is the demo we're going to talk about. This is the iPhone. So we got right now that my telemetry source now is the iPhone. This could be anything. It could be a website that's pumping out data. It could be a weather station. It could be whatever. For this case, it's the iPhone. Pumping it through. This is, in this case, is UDP. I can pipe it through TCP however we want. On the ingester, we've got a little ingester, which I'll show you. And we have the Node.js. So it's that simple server. It's bare bones Node.js server. Basically has one piece of code, which is the telemetry thing that has all the channels listed, and just basically a listener and interprets and just stores that data. So it's got real-time push, and it's got historical saving, and then responds to requests. So that's what's happening here. Then there's the web server side of things, which is the client serves the client GUI. It does the pushing, but also if the GUI, if the user, like if I was changing my timestamps or what I was looking at, or whatever, it would subscribe and unsubscribe to those things, and it shows it there. So that's the client there. So it pushes immediately, subscribes stuff, and then it responds to requests. But the idea of that is that the clients are lightweight, and they're only doing what a user or a human can see at one time, but all the data behind this is still saving all the data, still crunching all the data, doing all the stuff that we can do with it. So let's do the code dive. Now, this code for what I've got here is on GitHub. Now, it's a little bit of a work in progress in the sense that I need to write some instructions of how to put it on the cloud, but you just change an IP address and you're done. But it is available at this address. So the code for what I was just running, I uploaded it today. It's all fresh. So it is available for us to use. Okay, so let me do the code deep dive, and I'll come back and talk about a few things. So we're looking good on time. Okay, let me pop out of the presentation. Let me pull up 2 different codes. So what I've got on the left-hand side is I've got the esports. So I'll show you a couple different things just to demonstrate a few things, but I'm really going to do more of the code deep dive on the right-hand side, which is the iPhone. So the iPhone, there's kind of 3 parts. There's the client. Remember, that was the website. There was the web part. there's the server, which stores all the data, and that's the pushing part. And there's the ingester part, which is just the Python code or whatever code you want to use. It doesn't have to be Python, it could be whatever. But that's just the ingester. So let's start with let's work through the data flow in the way that would come. So start with the ingester. So on that guy, we have, the 3 different pieces. So it's multi-threaded. So we just have a few pieces that we can add. So let's talk about the ingester. So the ingester stuff is the kind of the mother, takes everything and does everything. And it is bare bones simple. We do have sys, we use threading. There's a recording option if you want, and we build up and just start the splitter on a thread. We start the recorder on the thread if we do select that, and then we have this, what here is the channels. So that's the channels. So the difference here across on the esports one is that instead of one channel, like that, one set of channels, I should say one packet. This has got one packet type for the iPhone. We have to have the 12 different ones and 12 different threads. So if you have more things, you have like a website you're pulling data from plus something else, you would just have multiple of these threads to ingest whatever sources you want to ingest. After that, you just start them up and it gets going. And that starts the splitter, it starts the recorder, and starts the thing that interprets the bits as well. Same thing here, it just starts 12 of them instead of one. So on the splitter, all that does is a listener on a certain port. So we got a port that it listens on, and it checks the code and pumps it out to a different port, which is the other one's listening on. In this sense, we have a recording port as well. So it can do that. This for the iPhone messages we found don't all come in once. They all come in chunks. And so we do have to buffer. So we in the splitter itself, it buffers until it finds a new line in the data that comes out of the sensor log, and then chunks that up and sends that to the live thing. The only difference in the esports version is that those come in specified chunks, and it's a bit more robust and it's a bit more easy. We can check even the length of them, and they're the same length every time. So on this one, the message comes in, we interpret the binary bytes into real numbers. That's what this stuff is, and then we just send it to the open MCT telemetry server as packet types, and then it ingests that. So that's the only difference there. This is just a binary version of that. This is kind of a comma separated version of that. So it's same kind of thing. The recorder, all it does, I won't go over that today, but it just buffers 1,000 messages and just writes it to a binary file on a separate thread every time. So you don't ever have threads running into each other on that one as well. All right, so it takes that data, chucks it over, and sends it to the server part. So this is the open MCT server. This is the part that stores it and also does the pushing of the live stuff. So in here, you'll notice there's only this iPhone sensor log, which we'll talk about. That's what we'll talk about mainly. Over here in this one, for the esports one, we have one for each channel. So you just duplicate this, and then you can have it interpret your messages. So really, it's really simple. There's a thing called the state, and there's a thing called the history object here. And it goes and gets your channels, which I'll show you in a second as well. So it's basically just a big object that keeps all the data, big set of arrays. That's all it is, and just shoves all the messages in there so it's safe, so it can be interpreted. But when we do have a way of storing that, So when the server's on, it just checks the size of the data, the messages coming in, make sure it's a good message. If it's bad, it just drops it because it doesn't want to. So you can put as many checks in here as you want. It does count it. I do have a feedback to make sure it's still live and still working well. But here's where we take it. So we do record when the message arrives, and then we just rattle through. So it's comma separated. So we just split that message by the comma, and we feed it into the history. Well, here's where we send the live. So we build a message. So we build a message with timestamp, the value, and the type of the channel that it is. And this is where we send it to the live thing. That's where we publish and push messages. And here's where we store. So we send that same message and that same data into the local storage that it can be requested from as well. And there's a couple of error things as well, but it's really as simple as that. So you have your messages coming in. whatever format they're coming in, and then you can just basically parse it and just save it and do what you want. So this part is the part you'd probably change if you changed whatever your input is. Again, on the esports side of it, it's a little bit, we just do it a little bit different. Like we got car data, there's header data, same exact thing. So this part here is exactly the same, but there is just a couple of loops to loop through as much data as that we're doing quite quickly. So that's all that is. Same stuff. You just change this part to interpret the channels that you're receiving. So then that sends it over. So that is the bare bones server, and it really looks as small as this. You've got real-time server, here's the Express Node.js server. Here's the plugin, the telemetry plugin that I just showed you. And you just create one of those objects, and you could create a real-time server and a history server. Those are the ones that do the communicating with pushing. Those are the WebSockets. And that's all those are. And you feed that telemetry into each one of those, and that's it. And it just starts the app. So again, on the esports side, it's just that times 12, because you just have 12 of those things that are running for each of the channels. So if you've got more sources, you just add another source and put it in there. So it's bang on easy to do. Everything else, yeah. So now that's bare bones. So the client side has all the GUI stuff. So I'm not going to go over the GUI stuff. I'll show you a little bit of that, but mainly wanted to just show how you plug in your stuff. And so I'll probably show less on the esports side, but more on this one. But there is, there's lots. I'll show both. So we've got the client. A lot of this is the GUI. So here's the source. There's APIs, images, and plugins and things like that. So here's plugins. Here's the gauges. And there's a clock, and there's charts and graphs, and you can add to this as well. We're also adding, you can also add them in here. So here's where the iPhone sensor telemetry plugin is. So you need to have one of these for each telemetry source. This is what receives it and does the pushing and back and forth for the web client itself. And so if we look at that, let's look. So here's the channels. So here's the iPhone channel. So you just build a dictionary of the channels. You got logging time. This is what comes out of the phone. So there's 82 channels, I think. So you have all these channels. You can just build up this little thing, and then you just build up the object. So it has a couple of sources for it by rattling through that list there, and then you have that. So this is where you change to do your channels. This plugin reads that file in, and then just builds. This is where it builds in the GUI those items in the OpenMCT GUI. This is where it builds those that tree of all the channels. That's all this code is doing. So we don't really have to change much of that except for the names and things like that. So almost hands off on that. What we did do, so this is the part that we had to change in the OpenMCT from the NASA stock version to the custom version here, is this real-time telemetry part. We had to build this out to work better with the cloud. And the way we did that is we kind of have it, if you're running on your own little laptop, things like that, the ports don't ever, the WebSockets don't ever drop and things like that. So it's pretty robust. But as soon as you go to cloud, you got to make sure that if the internet goes down for a bit, things like that, you got to build in some robust stuff. So we had to do a lot of stuff, like if it drops, it has to resubscribe to the channels, has to reconnect and do all those things, so that it's just trying to constantly just all of itself be robust and update. We also ended up having to add a heartbeat thing there, so that every 5 seconds it would just make sure that I'm still alive, I'm still alive, I'm still alive, still asking, so that those WebSockets won't drop. So we added all that information in, as well as we added in, like if you're running it locally, it's going to do a certain thing with the plot, with the URL. But if it's running on the cloud, we are running through the IP itself, but also underneath the telemetry. So when we are feeding back ourselves the telemetry across a different, slightly, just a sub URL of the other ones as well. So we added that stuff in there. Mainly, it was a lot of just building it out to be robust and fast and work not on the same machine as the client's actually serving. So that was that. And then that pushes that subscribes and does the pushing of the real-time stuff. The other part is the history. This is where it does requests. So we built this out a little bit, same thing. If it's doing an IP request locally, it will do a different URL than if it's on the cloud. It will use this telemetry sub URL telemetry to work with the server that's on the cloud, so it can communicate. So those are the main parts that we added in. just for robustness and for simplicity. So let me go over a little bit of how that's a little bit of how what we can do with the esports one is so that's the telemetry plugin itself. But then with the esports one, we're starting to build out more and more widgets that we can start to use. So we do want to build out stuff that is useful for the racing team, the esports racing team. So there's something called a circle map where it just takes the live gap, so I can pump. For that one, let me use let's perhaps use that one as an example where when we do, there's different components here. So so we have a few, so there's a plugin for it. I usually take one of these things and I duplicate it and do stuff like that. So this is the circle map one, which I got a spelling error in there. But that's the outside portion of the plugin. When we start building the view of that, that's when we start seeing some of the GUI. So we're using the view language here, but we have like templates, a templating system, and it's using SVGs. But we can put variables in here and have it, as it does its redraws on the screen, it's doing different things with the channels. And so this is a good example where we've got it's basically a chart. It's got 20 cars. They move around with the different gaps. That's taking channels. So we're taking the live timing from the game itself. So you got car 1, car 0. So scroll down through all that stuff. But you can automatically subscribe to channels. So once you start this plugin, it automatically, this is the list of channels it needs to auto subscribe to. So it'll grab all these channels at once so it can do all its computations and then display it to the screen. And then as you break down to this, you can save some of that data live, its current point. You don't need to save tons of data in this. You don't need to save the current spot of where those things are. So you build out this object where you say, okay, this is the default starting spot, but all as the flags and things move around, they get changed by the function. So color, different team colors, things like that. And then you just have the functions that do that. So it takes if I go down to where the channel comes in, where we subscribe. Yeah, so we have different refresh rates. So you can say, well, I want to refresh this at 5 hertz or 10 hertz, things like that. You can have, well, I need to get these sets of channels at a slower rate than the other ones because I don't need to update like the team name all the time. I just need to update this position all the time. So we can split the refresh. This is what goes and grabs the latest data from the server, and those requests are then brought back down. It then crunches the data and kicks off a refresh of the graphics and stuff as well. But yeah, so we have a few of these things going. We've got the circle map. We've got a full GPS map. So again, the GPS data comes through that they can go around there. We do have different gauges that are planned, and like a rev lights thing. You do a rev lights thing really easily. You could do weather. Telemetry decode, you can say, well, if the telemetry comes across in like binary or whatever, you can say, well, if it's 1s and 0s, that interprets to like certain weather conditions and things like that. We know from the game, but you just expand those out to be the different ones that you want. But that's basically how it's usually how they're mostly done is through a view templating system, but you can just build out and be whatever graphics that you want. And so the iPhone one, we don't have anything there. It's just the bare bones, but you can expand. You can make as many as you want. We've got GPS track maps. We've got rev lights. So yeah, this is just building more and more. All right, so let me just finish up the presentation, then we'll open up for questions. Let me get back to that. How does this apply to you guys? That's really what we need to talk about for the last little bit here, because yeah, this is gaming. This is, what does this really do? So let me talk a little bit about the future. So that was bare bones esports. We are building a system that's much like this. This is like an example race team strategy system. You'd have car telemetry on the left-hand side. You got lap data coming in as a source. GPS might be a different source. You got weather station coming in a different source. These can come through internet. They can come through fast connects, how you want. Load balancers, you can then split them up, how your channels come in. If you start to get to the point where you are topping up a single VM, free tier, you can have this expand and have it be a Kubernetes expanding ingester. So it just monitors how much load is coming through and it can expand itself to take in more messages. We do this where we take the messages, we split off one thread, one copy of that goes to the real-time system. So you can see that stuff real time. We also, we could record to a file or record to a database. So what we do is we take those messages, we pump it into OCI streaming, and then OCI streaming takes that and writes it into the database. Now, once we're in the database, we can build quite a system off that. We can replay off that, or we can start building tire models, safety car models, weather models from this massive data sets that we got from playing the game over and over again, fuel burn models, all those things. And that becomes the inputs to the stuff, such as stuff as like the Monte Carlo system, the strategy system. It will take inputs from your historical data. It'll take immediate current information and to do this predictive analysis, which again that's another scaling part that scales up with lots of VMs to run those simulations, and then it collates that information, sends that to the real-time telemetry thing where you have dashboards that are pumping back like, here's your best strategy, this is what it should be, and it'll be changing live in real time. That's pumped back via the internet to different race engineers. You got tire engineer, whatever their channels that they want to subscribe to, they use that. Or you can just log into the cloud and be looking at the data through some of the other tools that we've got. We've got, a lot of machine learning AI tools to build models and to look at the data and do analysis. This may not be real time, but this is the real time stuff. All right, so that's that. So really want to talk about this, finish off with the analogy, the race car analogy is, okay, we're not all running race cars. So what can we do with telemetry for my business, basically? So there's really four main categories that I kind of thought about with where telemetry is useful for racing teams. So the first one is performance tuning and the race car setup. So this is kind of the basic stuff. You'd be measuring the car, you're measuring the speed or things like that. In this case, let's measure the slip angle and the tire temperatures, and then measure that against lap time. And then what can I adjust on the car? I can adjust the suspension, the camber toe, springs, spring rates, roll bars, dampers, all that stuff like that. And I'm trying to find the optimal lap time, the lowest lap time, by changing those things. So I can change things, I can measure those things, and then basically find performance. Same thing actually works in your business as well. You can measure things, you can get you can feedback critical performance data immediately. And this can be in real time, and you can then be performance tuning your systems. So instead of performance tuning the race car, you're performance tuning your business, your systems, and things like that. The second one want to talk about is reactive monitoring to prevent like DNFs or catastrophic failures, or did not finish the race. So this would be more like you're monitoring things to stay inside of a window. So engine temp needs to stay in the window, pressures need to stay in the window. If it falls outside of that window, it could be a big error. So you can monitor your systems to make sure they don't fall outside of windows where you have huge failures of your systems. And so, and that immediately carries across to businesses. You want to be able to real time know if your parameters are inside of your KPIs or whatever. And if they start falling out, then you got to make decisions, and you want to avoid any catastrophic failures. Now, a third one, which is probably the biggest one, but this is where we do predictive modeling for your competitive edge. So you take your historical data. This is where the race team's doing like pit stop strategy and tire strategy and things like that. So you take all of your historical data. Is there risk models or risk simulations that you can do to continually be checking where you are to try and predict the future and try and continually run models of the future? And so you can make decisions now towards the better future rather than just going blindly into the future. So I mean, this is where you augment risk simulations with whatever data you've got to make strategic decisions. So that's a big one. I mean, that can be down to factory, if you got factories that are monitoring all your machine tools and when they're wearing out, so you can do all the logistics planning and things like that. You don't want to have a day where you run out of a certain tool on your machines. So it's that kind of stuff. You can monitor these things and do predictive models of things when they're going to wear out. Logistics and things. A lot of examples where that fits with business. And then the last one, I thought, well, actually, there is public data on your competitors out there too, and so you can monitor the public data on your competitors and do stuff with that. And racing teams do that. You actually get the speed trace of all the other cars, and so you can say, well, here's the speed trace of mine. Here's them, or I could do here's the theoretical best of everybody. And I can see where I'm weak. I'm weak in the slow corners, but I'm really good in the fast corners. Maybe I should adjust my drag levels slightly, or things like that, to kind of get get me closer to the fastest lap of my competitors. Same thing works with businesses. There is public information about your businesses, of competitors' businesses out there. And if you monitor those things, you can kind of feedback, and you can start making decisions based on that data as well, and basically turn any sort of weakness you might have into strength as well. So that's it from me talking at you. Now let's take a few questions if we've got time.
Thank you, everyone, again, so much for joining us. We really appreciate having you here today. And with that, I'll go ahead and end the session. We hope you have a great rest of the day and that we get to see you again next time.